For Mini Challenge 1, we have chosen to use the Commotion platform from General Dynamics Viz. Commotion is an info-centric, fully composable tool that allows very dynamic data visualization. Of interest here is that the gestures to move data between visualizations are simple drag and drops. Dropping the 2 p.m. dataset into the matrix of activity flag versus policy status values, we immediately notice the 1 policy status 5 circle. We can see that only one event occurred during this time frame of this type. Since policy status 5 means a compromised machine, this is of high concern. A drag of this circle into an IP address by business unit and facility chart determines the compromised machine lives in data center 2 and tells us its IP address. Another possible anomaly in the chart seems to be the high number of events at the policy status 1 and activity flag 3 intersection. Research discounted this as an issue. Returning to the top level again, we drop all the events from 2 p.m. into a chart that maps policy status to business units in order to get a roll-up view of the assets. Looking up the y-axis on the policy status 1 column, region 5 and 10 have no events, whereas every other region does. This depicts yet another anomaly. The final chart chosen for the 2 p.m. data is a map of Bankworld. We drop all of the events at 2 p.m. BMT into the map to look at health status based on location and time zones. At first glance, the map seems very much as expected. There are, however, only 4 large circles representing 4 of the 5 data centers. To further explore, the full data set is dropped into a new map. The circle representing the anomalous data center can be dragged onto a visualization showing the classes and functions of the machines in the data center with the events distributed over time. We'll also drag the circle of the other data center in the same time zone into another copy of this chart. Comparing events of the two before noon shows a significant difference in data center 5, which exists even at the start of the data set. After considering several possibilities, we chose to hypothesize that the center was down for patching purposes. When we drag branch offices surrounding the data center into another chart just for identification, we find that the data center is surrounded by region 10, which showed anomalies in the 2 p.m. dataset. We return to the full query of all events and drop it in the same chart we used in the 2 p.m. dataset showing business unit by policy status. The chart still shows the lack of policy status 1 values in regions 5 and 10. The possibility of data center 5 having the scheduled maintenance solidifies. To further research, we will drop all region 10 events into a chart that shows class and function of asset and the events they've had over time. We compare against a large region that has had no known issues. Moderate policy status levels seem to take the place of normal policy status levels, leading us to believe that this is a patching issue rather than a loss of assets. Perhaps these 2 regions are the last in a series of recent patch upgrades. To see the time-lapse of events through the business units, we drop all events into a chart that maps business unit versus time. There is an increase in red hues from the beginning of the dataset to the end of the time period covered. The spread of the coloration is concerning since we know that at 2 p.m. there was a single event with compromised status. By filtering the values to show only policy status 5, we get a much better view of the spread of the compromised machines throughout the system. Data center 2, which we know is ground 0, is included in headquarters. We drag all the events of the compromised IP into a chart that shows activity level over time. The activity flags seem normal at the compromised point. This does not preclude a remote login that succeeded or a worm that entered through a vulnerability on the machine.